Hi there, and welcome to this lesson. Now, in this lesson, we're learning about linear equations, okay? And on the linear equations, we're learning to solve equations from word problems. Now, I'm actually quite fond of, very fond of word problems, because word problems are a lot more practical. They're actually really interesting, but we'll find out shortly. And at this point, I'd remind you to set the video to play in 1080p HD. Very important that you do so you see everything clearly. And as the lesson progresses, if you have any issues at all, please feel free to get in touch. Okay, we would be more than happy to help. Okay, so let's jump right into the lesson. So linear equations, equations from word problems. Now, how do we solve word problems? What are word problems about? Um, Here's a word problem. Okay, so John, and the word problem says John thought of a number, okay, and he multiplied it by 7 and added 3 to it. If the result was 38, what number did he think of? Okay, so Hmm, this is interesting. Now we have that John thought of a number, so we have this young bloke, John, and John thought of a number, okay, and then he multiplied this number by 7, okay, and added 3 to it. Okay, so he had a number, he multiplied the number by 7, and then he added 3 to the result. Okay, and then the final result after adding 3 to it was 38, and it asks what number did he think of. Now, to solve this, we basically need to draw an equation from this word problem. Okay, and how do we go about doing that? Now we're going to do so in 3 simple steps. Okay, now when you have a word problem like this, the first thing you want to do is you want to actually read out the word problem. So read out the entire thing. Okay, digest it, try to understand it. Okay, and once you've done that, the next thing you want to do is you want to identify the variable. What is the unknown? What are we looking for? So basically at this point we're looking for a number, okay, the number that John thought of. Okay, and basically I'm going to call that number X. So John thought of a number and that number was X. Okay, now the next thing we want to do is we want to define the various parameters and identify their relationships. Basically, we just want to work with the information that we have. Okay, he multiplied it by 7 and he added 3 to it. Okay, so basically we have a number X and we've been told that John multiplied this number by 7, okay, giving us 7x. So X times 7, 7x. Okay, and then we're told that he added 3 to this number, so 7x, 3 to the result, so 7x plus 3, and his final result was 38. Now if you notice there, we actually have a simple linear equation, and we can actually now go ahead to our final step, which is obviously to solve said equation. Now 7x plus 3 equals 38, and we need to solve for x, the number that John thought of. Okay, and at this point we just move 3 over to the right, it becomes minus 3, so we have 7x equals 38 minus 3. We have that 7x equals 35, and when we divide both sides by 7, we have our final answer, x equals 5, which is the number that John thought of. Okay, and if you think about it, John thought of the number 5, he multiplied 5 by 7 and got 35, and when he added 3 to 35, he got a final result, 38. Okay, you see how this works? Very interesting. Let's try an example. Okay, so example 1, and example 1 says the length of a rectangle is 5 centimeters longer than its breadth. Okay, now if the perimeter of the rectangle is 42 cm, find the breadth of the rectangle. So we have a rectangle here, okay, a rectangle with a length and a breadth. Okay, and we've been told that the length is 5 centimeters longer than the breadth. Okay, and the perimeter of the rectangle is 42 cm. Find the breadth of the rectangle. Now how would we go about solving this? The first thing we want to do is we want to identify our variables, identify our unknowns, and at the moment we're looking for the breadth. So we have our breadth, and I'm going to call the breadth B. Okay, and we actually have another variable. In this case we have the length. Okay, the length is not given. Okay, so we'll have a length L. Now Now we're going to work with the information that we're given. Okay, so we have our breadth as b, okay, and our length as l. And one thing we're told in the question is that the length is 5 plus the breadth. Okay, the length is 5 centimeters longer than the breadth, so l equals 5 plus b. Or b plus 5 if you'd like to write it in that way. So another thing that we know is that the perimeter of a rectangle is 2 times the length plus breadth. Okay, so this is the formula for the perimeter of a rectangle, and we're told that the perimeter of this rectangle is 42 cm, i.e. 42 equals 2 times length plus breadth. Okay, now we were told that the length equals 5 plus b. Okay, so one thing we can do is we can actually substitute 5 plus b for length for l in our equation there. So basically we have that 42 equals 2 length plus breadth. Okay, we can actually bring in 5 plus b for length, and what we have in the end is we have 42 equals 2 multiplying 5 plus b, i.e. our length, plus b. Okay, and then when we work that, we end up with 42 equals 2 multiplying 5 plus 2b, and then we can go ahead and solve that equation. So 42 equals 5, 5 plus 2b, we have that 42 equals 10 plus 4b. Okay, and then we work that. When we move 4b over to the left and move 42 over to the right, we have that 4b equals 42 minus 10. Okay, and then we have 4b equals 32. We have b, when we divide both sides by 4, we have b equals 8. Actually really simple. Once you identify your unknowns, okay, you then try to understand their relationships, okay, and then you generate the equation, and once you have the equation, you just solve it and you get your answer in the end. Okay, so let's do another example. Now example 2, and example 2 says, if Frank was half his current age 5 years ago, how old is he now? This is interesting. So we have this young guy Frank, okay, and 5 years ago Frank was half his current age, and we've been asked to find his current age. So first thing we're going to do is we're going to label his current age X. Okay, so that's what we're looking for, his current age. Okay, and now we're going to work with the information that we have, and the first thing we were told is that his age 5 years ago, okay, was X minus 5. Okay, because it's 5 years ago, so basically his current age minus 5 would be his age 5 years ago. We're also told that his age 5 years ago is half his current age, i.e. age 5 years ago would be half of X. Now that we have this information, I think it's fair to say that X minus 5 equals 1 over 2X. Okay, basically if his age 5 years ago is X minus 5 because it was 5 years ago, and his age 5 years ago was half of his current age, so it's fair to say that X minus 5 equals 1 over 2X. And now we have our equation, and we just go ahead and solve this equation. So we have X minus 5 equals 1 over 2X, X minus 5 equals X over 2. We bring X over 2 over to the left and bring minus 5 over to the right, and we have X minus 2 equals 5, and X minus X over 2, sorry, not minus 2, is X over 2, and basically from this point we just cross multiply and we have that X equals 10. Very simple, very straightforward. Let's do a final example. Okay, a final example, example 3. And example 3 says a man travels 29 kilometers on a good road at a certain average speed. Okay, so we have this man traveling, okay, and he travels 29 kilometers on a good road at a certain speed. So the speed is not given, okay, and then he travels on a bad road. On a bad road, he reduces his speed by 42 kilometers and found that it takes him the same time to cover 15 kilometers on the bad road. Now find the average speed on the good road. Okay, so We have this man and he's traveling, okay, and he's traveling on a good road, okay, and he travels 29 kilometers on this good road, okay, and then he travels on a bad road, okay, and to travel on that bad road he decides to reduce his speed. Basically it's a bad road, so he decides to move a bit slower, okay, and what he found is, with traveling at that speed, at that reduced speed, it takes him the same time to cover 15 kilometers, okay, which makes sense. Basically, if he reduces his speed, it will take him the same time to cover less distance, okay. So if he travels 15 kilometers on the bad road, and we've been asked to find his average speed on the good road, okay. So first thing we want to do is we want to identify our variables, identify our unknowns, okay. So our first unknown is his speed on the good road. So his speed on the good road is x, okay. We're told he traveled at a certain average speed, so let's call that average speed x. Now we also have the speed on the bad road. So the speed on the bad road we're going to call y. Now, remember, what we're looking for is we're looking for the speed on the good road. So we're actually looking to work for an equation that would give us the speed on the good road x. Now, what information do we have in the question? So the first thing it tells us is that the speed, he reduces the speed by 42 kilometers on the good road, i.e. the speed on the bad road. The speed on the bad road is 42 kilometers less the speed on the good road, i.e. y equals x minus 42. Now, the time it takes him to cover the distance on the good road is going to be distance over speed, okay? So remember that his speed on the good road is x, and he traveled 29 kilometers on the good road. So we have 29 divided by x. Now, the time it took him to travel on the bad road, basically he covered 15 kilometers on the bad road, and the speed on the bad road is y. So time equals distance over speed. So we have distance 15 kilometers divided by y. Now remember that y equals x minus 42. So we have that the time on the bad road could also be expressed as 15 over x minus 42. Okay, so we have some interesting information here. Now, the final information we're given is that it took him the same time to travel on the good road as it did on the bad road. Okay, so basically he covered 29 kilometers on the good road and 15 kilometers on the bad road within the same period of time, basically within equal periods of time. So the time it took him to travel on the good road was 29 over x. Okay, the time it took him to travel on the bad road was 15 over x minus 42. I think it's safe to say that 29 over x equals 15 over x minus 42. And I think we have arrived at our equation. And from this point on, really simple, we just have to solve, and we have that 29 over x equals 15 over x minus 42. We just cross multiply, and we have 29 multiplying x minus 42 equals 15x, okay, and then we have 29x minus 1228 equals 15x, and we have that when we bring 15x over to the left and we'll bring minus 1228 over to the right, we have 29x minus 15x equals 1228, and basically 29x minus 15x equals 14x. So we have 14x equals 1228, and we divide both sides by 14, and it will give us our final answer. X equals 87 kilometers per hour. Okay, and that is the speed on the good road, which will bring us to the end of this lesson. Very interesting lesson. Word problems, very interesting, very practical. And one thing, what you need to watch out for, first thing you need to do, first thing, read the question, read the full question, okay, read everything out, all right, and then first thing, identify the variable. Once you've done that, you then work with the information that you're given in the question, okay, to find the relationships between the variable and the numbers you're given. Okay, and then finally you generate the equation and you solve it. And yeah, bye for now.